Mike Brown, an American astronomer and master of the Kuiper Belt, also called the CR Belt, has provided fascinating insights into this distant region of our solar system. The Kuiper Belt is a deep, frozen record of the early history of our solar system. It is a frozen region at the farthest reaches of the solar system, and NASA has recently revealed shocking new details about what is really hidden in this mysterious zone, which has been poorly explored until now. The latest discoveries could prove that the history of our solar system was very different from what we previously believed. Strange objects and potentially an unknown planet could completely change our view of the world. Was it a mistake to have paid so little attention to this region for so long? The Kuiper Belt begins about 4.5 billion kilometers from the Sun and extends to 7.5 billion kilometers. It is the outermost zone of our solar system. We have only discovered and explored a small part of these astronomical treasures and their peculiarities. Some objects here have puzzled scientists in terms of size and mass. The Kuiper Belt is a massive band of ice, rock, and frozen gases, up to 20 times larger than the main asteroid belt between Mars and Jupiter, and contains 20 to 100 times more mass. This region also contains another peculiar phenomenon: the scattered disk, a zone of celestial bodies spread irregularly, extending far beyond the normal boundaries of the Kuiper Belt. The lighting conditions in the Kuiper Belt are extremely weak. This region is so distant from the Sun that the few rays that reach these distant objects only produce a pale glow. The light is barely enough to penetrate the icy darkness. This low level of illumination not only makes the Kuiper Belt extremely difficult to explore, but it is also abnormally cold. However, this extremely cold environment is ideal for perfectly preserving the primordial materials from which the bodies in this region formed. Researchers believe that most of the objects in the Kuiper Belt have not changed in billions of years, making it an important window into the early days of our solar system. The Kuiper Belt is not just a place of darkness and cold. It is also a dynamic zone where many dwarf planets are located, such as Pluto, Eris, Haumea, and Makemake. These objects offer a unique insight into the chemical creation and physical conditions of the early solar nebulae from which our solar system formed. In addition to dwarf planets, there are countless other objects, including comets and small icy bodies, which could contain important organic compounds that may help us understand the chemistry of life. So far, only 2 spacecraft have visited and explored this distant region: Pioneer 10, which flew past in 1983 but didn't encounter any specific objects in the Kuiper Belt, and New Horizons, which passed through the Kuiper Belt in 2015. During this mission, New Horizons discovered one of the strangest objects in the solar system, Arrokoth, also known as Ultima Thule, which is so different that it defies certain physical rules. It is a timeless relic of immense value. Did you know that asteroids and comets are original relics from the earliest days of our solar system, when the Sun was just beginning to form from an incredibly hot, rapidly rotating disk of dust, and other rocks and objects were already forming in the early plasma? These objects have remained unchanged to this day in certain regions of the solar system. Previous research has shown that asteroids and comets are composed of an astonishingly high degree of mineral and organic substances, such as magnesium, sulfate, iron, copper, and even amino acids, which also make up our DNA. These organic substances are the building blocks of life, plants, our bodies, and much more. It is not surprising that these substances were apparently present in abundance in the early days of the solar system. This suggests not just the emergence of conditions favorable to life, but that life itself may have been anticipated from the start, and it may even be unusual that there is only one planet with organic life in our solar system. If we push the idea further and consider the latest discoveries in astronomy and cosmology, we cannot currently exclude the possibility of stages rich in life on other planets. We suspect the presence of organic life on certain icy moons that are warm in their depths and could harbor liquid oceans. Computer simulations have also shown that Mars may have once had an atmosphere and liquid water. Even on Venus, we cannot exclude the possibility of life. It is precisely because we know so little about the past that contemporary witnesses, such as objects that have remained unchanged since the early days of the solar system, are of such interest to science. Research on the Kuiper Belt has only just begun. Welcome to the trans-Neptunian zone. It is now widely known that a whole series of new small planets have been discovered in the Kuiper Belt, and around 2,000 of these trans-Neptunian objects are currently known. Pluto is the largest of these planets, and it was because it resembled many of these other trans-Neptunian objects that it had to relinquish its status as a planet in 2006. Since then, Pluto has officially been classified as a dwarf planet, with the unappealing designation 134340. Pluto was discovered in 1930 by the astronomer Clyde Tombaugh, and at the time, there was great excitement among the public over the discovery of another planet. After Pluto, no new planets were discovered until 2005, when Eris appeared before researchers' telescopes. The exploration of the Kuiper Belt began seriously in the 1990s, but it wasn't until several years later that scientists understood its true size and nature. Between Mars and Jupiter lies a similar region, the asteroid belt, which contains about 1.9 million objects. The asteroid belt was discovered because researchers suspected the presence of another planet. Instead, 1.9 million individual objects appeared, and it was sometimes thought that these might be the remnants of a destroyed ninth planet. However, these hypotheses were not confirmed. In fact, researchers have been looking for another planet in the Kuiper Belt for decades, initially considered the 10th, and now the 9th after Pluto's downgrade. This does not mean that there are many dwarf planets, but some astronomers believe there must be another body beyond Neptune, slightly larger than Neptune but smaller than it. So far, the legendary Planet 9 has not been clearly identified, confirmed, and the research to determine whether it really exists or not is still ongoing. This hypothesis is best explained by the orbital irregularities of certain small planets in the Kuiper Belt, which are most coherently explained by the existence of another planet. Some irregularities in Neptune's orbit could also provide clues. It is surprising to note that researchers have been studying our outer solar system for about 100 years. Since that time, we have had telescopes that allow us to clearly observe this distant region. However, despite the telescopes being able to reach the Kuiper Belt and beyond, it is often light that complicates the research. For example, it is much more difficult to study our closest stellar neighbor, Alpha Centauri, with telescopes than the Kuiper Belt, which is much closer. Invisible objects such as planets or even entire groups of smaller objects in the Kuiper Belt or the scattered disk are usually noticed primarily because of the gravitational force they exert. Researchers then approximate where one or more of these objects should be, and then they conduct targeted searches. Such gravitational irregularities were first suggested by Gerard Kuiper in the 1950s, who proposed that there was much more to be discovered beyond Neptune, especially numerous unknown objects in the scattered disk. Almost no one knows of another region of the solar system that researchers call the scattered disk. This fascinating and enigmatic region of the solar system is partly linked to the Kuiper Belt but also extends far beyond it. This disk-shaped area begins roughly at the outer limit of the Kuiper Belt and stretches several million kilometers into space. Some objects in this region have orbits that take them as far as 150 million kilometers from the Sun. Due to this enormous distance, the scattered disk is one of the most distant and least explored regions of our solar system, even compared to the Kuiper Belt. What stands out about the objects in the scattered disk is the eccentricity and inclination of their orbits. These unusual orbits are likely the result of gravitational interactions, particularly with Neptune. When the giant gas planets of our solar system settled into their positions, their powerful gravitational pull disturbed the orbits of many smaller icy objects that were close enough to be affected by Neptune's gravity, but not ejected from the solar system. These objects ended up in the scattered disk. It is assumed that the scattered disk acts as a reservoir for comets, and some of these objects are periodically drawn toward the Sun, occasionally entering the inner solar system. The comet Hale-Bopp is a well-known comet that probably originates from the scattered disk. This comet became famous after its spectacular appearance in 1997 when it was visible to the naked eye from Earth for several months. Hale-Bopp is classified as a long-period comet, and its orbit takes it deep into the outer solar system. Its orbit has a very high eccentricity, which is typical of comets originating from the scattered disk. This object takes about 2,500 years to complete one orbit around the Sun. Anyone who saw Hale-Bopp in 1997 witnessed a very rare event. From a scientific standpoint, the scattered disk is particularly interesting because it provides data on the dynamic processes that shape the outer solar system. By studying the orbital trajectories of all the objects in this region, astronomers can gain valuable insights into the movement of the planets and the initial conditions of the solar system. It is certain that our solar system did not always look as it does today. It probably took millions of years for all the objects to settle into their current positions and for the orbits of most of the planets to become stable, bringing order to the system. Imagine what it must have been like when the planets were still jostling for their positions in the system, and many asteroids and comets were racing through the solar system. During that time, collisions were frequent, and our Earth also experienced moments when comets rained down from the sky. Some researchers even believe that this is how water and, eventually, life appeared on our planet. Comets are made mostly of ice, and their organic components could make them true celestial messengers of life. However, the origin of the initial spark that led to the emergence of bacteria, from which more complex life forms developed over the course of evolution, remains a mystery.